First, let's start with your definition of your pi. Your pi is defined as the ratio of the circumference of a circle to the diameter of the circle. And this ratio for any circle is found to be 22/7. That means if I take a circle whose radius is 1 centimeter, whose diameter is 2 centimeter, if I calculate the circumference of this circle and divide it by its diameter, I am always going to get a number that is your 22/7, which comes out to be approximately equal to 3.14. Now, even if I take a circle which is a much bigger circle where we have radius of 5 centimeter, diameter of 10 centimeter, again now if I calculate the ratio of circumference of this circle to its diameter, again I am going to get a number that is your 22/7, and this number is what we call as pi. Pi is going to help us to measure angles, and pi also helps us to convert any degree into angles. The conversions are as such as given here. We take 180 degree, which is the measurement of a straight angle, and we call it equal to pi. That means we get 22/7. This 180 degree can be written as 1 degree taken 180 times. So we can write 1 into 180, that is your 180 degree, equal to pi radians, or we can write 1 degree is equal to pi by 180 radians. Since we know the value of 1 degree now in terms of your radians measurement, we can write 10 degree must be equal to 10 times of 1 degree. 1 degree we already know it is pi by 180 radians. So 10 degrees will be equal to 10 times of pi by 180 radians. This pi by 180, you can come and write 3.14 by 18 approximately, and that is the measurement of your 10 degrees in radians, which comes out to be 0.174 radians. Similarly, if I am talking about 90 degree, I have to multiply 90 times of 1 degree, which is equal to 90 times of pi by 180, because this is your 1 degree, such that we get pi by 2, because 90 and 180 gets cancelled and we get 2 here. Pi is 3.14. When we divide it by 2, we get 1.57 radians. Also, we can have measurement or conversion from radians into degrees. For that, we write pi radians must be equal to 180 degree, or we can write pi times of 1 radian must be equal to 180 degree, because you can treat this pi as a number. Then we can have this 1 radian must be equal to 180 degree divided by 22/7, that is your pi. So this is what we are going to use to convert any radian measurement into degree measurement. Your left hand side is radian, your right hand side is degrees. So 10 degrees can be written as, 10 radians can be written as 180 degree divided by pi times 10, and this is the measurement in radians. And 30 radians can be written as 180 degree again by pi into times 30. Again this is the degree measurement of your 30 radians of angle. You also have problem regarding your arc length is relation with radius of a circle and the angle theta that we measure in radians. So suppose we have this arc here. The arc here is AB. It is not the whole circumference but part of a circle, such that its length we have taken to be L. Now this circle has a radius capital R. So this line, that is your OA, has a radius or value R, and your OB is also a radius here. So your OB is also equal to capital R. Now the relation that is found between this angle theta, your radius R, and the arc length is this angle theta here must be equal to this arc length divided by the radius of the circle that we have taken. It does not matter whether you take OB in place of R, or you can also take OA in place of R. Now when I isolate this diagram, it's going to look like this. and the relation still holds, that your theta is equal to L by R. Now what approximately we can do is that we can take this theta, make it very small, and when we do that, our diagram is going to be equivalent to this diagram, such that you can see here the angle is very small and the point A and B are very close to each other. Now what approximately we can do is that this line here, or the arc AB, can be treated like a straight line, such that this angle here can be taken as 90 degree, and even this angle here can be taken as 90 degree approximately. So always remember, when your angle here subtended by an arc is very small, then these two angles that we have here can be taken approximately or almost equal to your 90 degrees. And you can imagine this whole arc not to be an arc but a straight line. In that approximation, again I can use the theta equals to arc length, that is your AB, divided by radius. Now your radius is either can be this or this, so you can write R, or let's just simply take for the time being OA, or I can write AB again, the arc length, or the radius as OB. Now with this, what you can also say is that if this triangle is seen as a right angle triangle, such that your theta is very small, what we can also say is that I can take your tan theta here, which is simply the ratio between the perpendicular by base. Here AB is the perpendicular, as you can see. The side opposite to the angle is a perpendicular. Now base can be taken as this, so we can write OA for the base, but we know that even this can be taken as base because the measurement of this is almost equal to measurement of this, so we can also write OB. Now if I write here OB, it is also suitable for us to write or take it as not only perpendicular by base, but we could have also seen it as perpendicular by hypotenuse. So that's why we can also use sine theta. And you have just learned just now that we can write this arc angle, that is your theta, equal to AB by AO or AB by OB. So that means I can write tan theta equals to, or let's say almost equal to a sine theta, or almost equal to that arc angle theta. This is a valid relation which you might be using later on, provided your theta is very small angle. That's why some of you might have doubt, where we have taken a heavenly object, a spherical heavenly object, and from one single point where we have another heavenly object whose size is very small, we can treat it like a point, and I can say that we are measuring or looking at this heavenly body from a single point, looking at the edges or the far end of this heavenly body, such that we are looking like at point A and B. Now we know this heavenly body is going to be so far that this angle here that we have, theta, can be taken as very small. Now under this condition, as I told you earlier, this line here, that is your AB, can be treated like a straight line, which is actually can be also treated like an arc. So still we can apply a formula where we have L here, the length of the arc. This is like your radius, so that's why we apply theta equals to length of the arc divided by your radius. Now this length of the arc is nothing but the measurement of diameter of this heavenly body. That's why we have written it to be small d by this r. In our notes, I think we have written capital D. So that's why we have this formula where we have theta equals to d by capital D. Now always remember, the definition of theta comes as ratio of the circumference of a circle to the diameter of the circle. Now this definition is valid provided we take this angle theta only in radians measurement. That means whenever we have written this formula here, we are always going to make sure that this theta is measured in radians. Now some of you have problem in your measurement of angle, which we have written as arc minute and arc seconds. Arc minute and arc second are simply units used for very small measurement of angles. For example, as you know, if this angle, that is your angle AOB, I've taken it to be equal to 1 degree, which is the 1 degree that you measure using a protractor. I've drawn it big, but it's actually a very small angle, that is your 1 degree. Now what we do is that we take this 1 degree, divide into 60 divisions, equal divisions, such that the measurement of the first division that we have here, we started calling it 1 arc minute. So you can see already arc minute is a very small measurement of an angle, that is 1/60th of a degree. That means you have divided your degree into 60 parts, and that one part that you get after those 60 is what is known as 1 arc minute angle for us. To convert your arc minute into degrees, you simply have to take the degree that you have and then divide by 60. Or therefore, if I have 5 arc minutes, it simply means I have 1 degree divided by 60 times, then 5 times of that. Sorry, I wrote here double dash, but it's actually 1 dash. So this is what is your 5 arc minutes, which represents 1, 2, 3, 4, 5 equal parts of this 60 divisions of your 1 degree that we have. Next, we again have a much smaller unit to measure your angle, which we call it arc second. Now 1 arc second is simply defined as 1/60th the angle, that is 1 arc minute. So you saw already we have arc minute, which is, let's say, is this. We divide this arc minutes again into 60 parts. So you can already imagine it's going to be such a small angle that we have. Now that arc minute, when I divide by 60, what we get is your arc second. Therefore, 1 arc minute is replaced by 1 degree divided by 60, and then again we have this 60, so that now we can write this 60 can be multiplied with this, so we have 60 into 60, or a 1 degree divided by 3600. This is what is known as 1 arc second for us, which you already can see is a very or much smaller unit of your angles. These two units of angles are going to come in handy when we are going to use very small measurements of your angles. Now suppose if somebody writes 1 arc minute and 30 or 30 arc seconds, and if they ask you to convert this into angles, what you're going to do is that you can think of it like a watch where you have minute hand and seconds hand, and this is like the time measurement, but here of course it is an angle measurement. So 1 minute and 30 seconds is like writing 1/60 of a degree, that is for your 1 minute, and I must add it with 30 seconds, and 30 seconds is like 30 times of 1/3600. So you can see already I've converted your arc minute into degree by using 1/60, and I've converted your 30 arc seconds by dividing by 3600. Of course, we are multiplying by 30 because we have 30 over here. When I add these two numbers, I'm going to get the whole measurement, that is your 1 arc minute and 30 seconds of angle in terms of degrees. And you can see in terms of degrees we are going to get a very small number because we are dividing a very large number. Now some of you have problem with what is parsec. So for that, let's try to understand somewhere here. We have this diagram where I have taken approximately an arc, this one, that is your 3 centimeters long. Now what I'm doing is that I'm taking a point like O and measuring the angle made by this arc, and I'm getting around 45 degree. Now this distance here, 6 centimeter, I can tell you is the radius. Now if I do the same thing, such that I'm taking the same arc length, that is your 3 centimeter, but I'm taking a point O much closer, as you can see here. If I do that, then this radius that I'm going to get cannot be anything else, but it will be less than the 6 centimeter we got earlier, is going to be 2 centimeter. So what I have done is that I've taken the arc length again 3 centimeter, but the point O that I was talking was very far. Now the point O, this one, is very close. So this radius of course is going to be close. And what you have and what you can see from here is that this angle here is going to become big. So similarly, if the point is shifted from here to let's say somewhere here, again I can tell you is that if I measure the angle now from this point, I'm going to get an angle which is much bigger, and this radius however is going to become much smaller. So suppose I tell you I take the arc length to be 3 centimeter and I go very far from this arc such that the radius is very big, then automatically you can see the angle is very small. Now during your derivation or definition of your parsec, we have done the same thing. We've taken an arc length which I've drawn it very small, but actually it's a very large distance, that is your 1 AU, such that it represents the distance between the earth and the sun, and I've taken an angle not close but very far, such that the angle here is only 1 arc second, that means 1 degree divided by 3600. Since it is such a small angle, you have seen if I take the point to be very close, I'm going to make a very big angle, but that is what we are not doing right now. But we have taken this angle to be so small that this radius that we have here is quite large, and this radius that we have, we start calling it 1 parsec. Next, what you have done is simply calculated the value of this 1 parsec, which is the value of your r, by using the formula that is your theta, arc length, that is your L, which is 1 AU, divided by radius. Simply we have written r is equal to L by theta. L is your 1 AU, so we have written 1 AU. Your theta is 1 arc second, we have written 1 arc second. But obviously, as you know, we cannot use arc second here, we have to convert into radians. So we are going to get approximately 1.5 into 10 to the power to the power 11 meters divided by theta, that is your 1 arc second, and 1 arc second you know is 1 degree divided by 3600. This is the measurement in degrees, but since we are going to calculate in radians, we must write pi by 180. When we do this calculation, you have seen we get a value of r, and whatever value of r we get, we start calling it 1 parsec. So you can already imagine 1 parsec is such a large distance we have to go, such that this angle here is so small, equal to 1 arc second, such that the radius of this arc we will start calling it 1 parsec. Obviously, your parsec is related to meters, so we have calculated this whole part here and we got 1 parsec equal to so many meters. So that is how we define your 1 parsec. It is nothing but the radius of an arc which an arc is making, such that the arc is of length 1 AU and the angle subtended by this arc at a very far point is only 1 arc second.